1.8. Describe the Doppler effect in sound waves and how it is used in ultrasonics to obtain flow characteristics of blood moving through the heart. Very important procedure and very important application used in medicine. So the Doppler effect, which is what we learned in the 11 in the World Communicates, can be also used for medical purposes. So it is the apparent change in wavelength of a wave when it is produced by a source moving relative to a stationary observer. When a source of a sound wave moves towards the observer, the waves are compressed, the wavelengths are shorter, and the frequency heard by the observer is higher. The converse is true when the source is moving away from the observer, so the sound waves are spread across, the wavelength is longer, and the frequency is heard by the observer is lower. So the Doppler effect also happens if the source is stationary and the observer is moving. If a pulse of ultrasound reflects off a stationary boundary, it will return with the same frequency and the wavelength as was emitted. If the boundary is moving away from the transducer, there will be a Doppler shift effect. The waves will undergo a Doppler shift on the outward and reflect journeys, producing the double Doppler shift. So we learnt about an ultrasound. So an ultrasound in our previous videos was in 1.1 to 1.4, but ultrasound is used in blood flow measurement and typically has a range between 5 and 15 megahertz. The moving boundary comprises of surfaces of multiple red blood cells, as an individual red blood cell is too small to create its own boundary. We've learned that about acoustic impedance. So the Doppler shift is typically a change of frequency up to 3 kilohertz. This value is positive when blood flows towards the probe and is negative when the blood flows away. The next paragraph goes to then talk about colors, and if you type in Doppler shift with the heart, you will see that you get the red and blue colors, okay, indicating the flow of blood flow. So the problem is a color change can indicate increased velocity, indicating a narrow artery, and that's what we don't want. Color intensity can indicate flow volume, while mixed colors can indicate turbulence due to a partial blockage, and that's what we don't want in the heart. The wrong color can also indicate a leaking heart valve, which is what we also don't want. So you can see how looking at the Doppler effect and characteristics of blood moving around the heart is important when we're looking at medical physics.